So, good evening, viewers. So, today we'll discuss definitions involved in spherical mirrors. So, concave mirrors and convex mirrors, they are called as spherical mirrors. As we studied already, concave mirrors, they are bulged inside, and convex mirrors, they are bulged outside. So these definitions of what is concave mirror and convex mirrors we know, and these concave or convex mirrors, they are called as spherical mirrors. This is the diagram we need to remember in case of concave or convex mirrors that are taken as spherical mirrors. So with this idea, let us try to understand various definitions involved in case of concave and convex mirrors that are being considered as spherical mirrors. So the first one, let us take an example, concave mirror. Let us take an example, concave mirror. So let us consider a part of concave mirror M to M dash, and midpoint of the mirror is called as P, pole or vertex, we say this point, and C happens to be the center of the mirror, and the center of the mirror, and let us stretch the line that passes through the polar vertex of the mirror. This line that passes through the center pole of the polar vertex of the mirror is called as principal axis. This line is called as principal axis. This line is called as principal axis. What do you mean by principal axis? The line that passes through the center of the mirror and the polar vertex of the mirror. This line is called as principal axis. Then one more definition we have. What do you mean by principal section? A part of the mirror M to M dash containing center of the mirror, polar vertex, and the line containing principal axis. All this forms a principal section. Principal section we say. And the next definition, what do you mean by principal focus? What do you mean by principal focus? Principal focus, we can define it for concave mirror and also for convex mirror. Also convex. Let me draw the convex mirror. Let me draw convex mirror. Convex mirror. So let us try to draw so this is the part of the mirror M to M dash. This is the convex mirror. So let us take this as polar vertex. Then this is the principal axis line, and let this be the center of the mirror C, and let this point be the principal focus. Let us try to define principal focus. Here F represents the principal focus. What do you mean by principal focus? The principal focus is the point on the principal axis only. This is a point over the principal axis. In case of concave mirror, all the rays tend to converge at this particular point. How it converges? Like an example of real image in case of concave mirror. Let me keep an object like this, and the rays of light there that hit the mirror, and all the rays of light tend to converge at a particular point, tend to converge at a particular point. Let us take a few more rays of light that will hit the mirror, and it will, after reflection, all the rays of light tend to converge at a particular point, and this point is called as principal focus. And the length from principal focus F to P, this distance represents focal length. So this is what definitions in case of concave mirror, same definitions that applies to convex mirror also. So let me keep the convex mirror, let me keep an object in front of a convex mirror. Now the rays of light will tend to hit the mirror like this. Rays of light tend to hit the mirror like this, and always in case of in case of convex mirror, you will get an virtual image like this, and here the rays of light tend to diverge like this. They tend to diverge from the point. Diverge away from the point. This is called as principal focus in case of convex mirror. Convex mirror, we will get the virtual image backside of the mirror. You will have this one virtual image, and it's a erect one like this. So this is what in case of image formation in case of convex mirror. So in this video I try to explain basic definitions in case of spherical mirrors. So basic definitions, or what do you mean by center of the mirror, and center of the mirror, or else we can call this as the center of the sphere. It is represented by C, and the midpoint of the mirror is called as polar vertex. Second definition. Third definition is principal axis, the line that passes through the center pole or vertex. This line is called as principal axis. And what do you mean by principal section? The area of the mirror containing center, principal focus, principal axis, then this is the midpoint of the mirror and a part of the mirror. All this places together, it is called as principal section. And principal focus, in case of concave mirror, if it is a real image and image is inverted one, and image is formed in front of the mirror, all the rays tend to converge at a particular point. This is called as principal focus. It is formed on the principal axis only. And in case of convex mirror, we know that the image is virtual. In this case, at this particular point F, the rays of light tend to diverge from this particular point, focus point. And what do you mean by focal length? Last definition. The length from principal focus to midpoint of the mirror. So this length is called as focal length. So all these definitions are important, and just I explained, and I summarized all these definitions involved in spherical mirrors. Thank you. So, one more definition we left actually. So the definition is radius of curvature. Radius of curvature. Radius of curvature. Let me draw a concave mirror like this. Let us take center C. Then this is the principal axis. This point is polar vertex, and from center of the mirror to the mirror or polar vertex, or from center of the mirror to the mirror section M to M dash, this forms the R. R is called as radius of curvature of the mirror. Thank you.